magnetism. You see, magnet was first of all discovered by Magnus scientist. He discovered rather magnet first of all. It was discovered in Asia Minor, and first of all it was named as magnetite. Its complete name could be given as magnetic dipole, and that would be analogous to electric dipole. Dipole, when we draw a magnet, bar magnet, this is the way how we represent the magnetic dipole. In a magnet, there can never be a single pole. Magnet itself always means two poles, that is north and south. We have to remember that the two poles are never separable. Means whenever you talk about a magnet, the smallest character that is going to be obtained in the magnet will be a magnetic dipole. Magnetic substances are always attracted by natural magnets like iron, but non-magnetic substance simply means wood, plastic, glass, which are not attracted by the magnet. Henry discovered electromagnet, Henry law you study, and then finally Gilbert introduced the concept of bar magnet. For getting the magnetism or for obtaining the role of a magnet, we have to follow many practices like you see magnetic needle, current carrying coil, current carrying solenoid also behaves as a magnet. We also use horseshoe magnet that is always in the shape of letter U. The two poles here would be north and south, and bar magnet is the most common. You see, interestingly, you can have a magnet in which there are three poles like this. It could be dealt as a single magnet in which you are having three poles only. Three poles. This is one bar, and you could say it's a combination of two magnets. The south pole of both the magnets have joined together to form a single magnet, and that way you could say it is a single magnet with three poles. That is shown over here. And when you talk about a pole, it is always to be compared, or you might establish the analogy of a magnetic pole with the electric charge. But charges are all separable. You could have plus charge, minus charge separately. Here, single pole does not exist. There is no meaning of monopole or single pole. You see, North Pole could be compared with positive charge. South pole could be compared with minus charge. Positive charge always introduces the field away from it. Likewise, here also, North pole will always introduce or produce the magnetic field away from it. Similarly, South pole will always produce the magnetic field towards it. Then North Pole and South Pole both will experience the force because of the magnetic field quite in the same manner as charges experience the force in the presence of electric field. When you place a pole, might be south or north in magnetic field, north pole is going to experience the force in the direction of the field, and south pole will experience the force opposite to it. That has been shown over here. Now, one pole could be analyzed in terms of magnetic pole strength, or sometimes we confuse it with magnetic moment. You see, both are represented by the letter M, small and capital. But here, first of all, we are getting introduced to pole strength. Every pole is characterized in terms of pole strength always, that has the unit ampere per meter. Pole strength depends on the area of the pole, the nature of material, and also the state of magnetization. One thing is very important: whenever you are having a magnet, magnet could be magnetized to a certain limit only. Similarly, you could say any pole has the subject to the saturation value, means that pole could be magnetized up to a certain limit only. Magnetic strength is always maximum at the poles, and that's going to be minimum in the middle, like here. See, this is the region where you are having the minimum magnetic strength, and near the poles the magnetic strength is always greater. Now suppose you are having a magnet and you want to demagnetize, means you are interested in just finishing the character of that magnet. What will you have to do? You have many options, like you could hammer it, you could start heating of that magnet, you can place the coil and pass AC. Magnet should be within that coil. That means around that magnet, if you place a coil and pass AC through it, this would get automatically demagnetized. Most often term here is unit pole. When you say unit pole, you see unit pole can never exist. So unit pole doesn't mean one pole. It means a pole having pole strength equal to 1, that would be known as unit pole. As in the case of unit charge, you always talk in terms of 1 coulomb charge. Similarly, if somebody says unit pole, it simply means its pole strength is 1.